Good morning. My name is Larry White. I'm the UIL Number 6 Contest Director and the UIL State Mathematics Contest Director. You see my email there in case the coaches or teachers need to email me about anything. And you also see the academic STEM page, which you need to bookmark so that you can see things as we go along. This is the second recording for the 4-part student activity conference recordings that we are doing since we can't meet face to face. I do miss your bright, shining faces, but this is what we have to do to the situation we're in. In case you haven't been there, on October 1st, several things were posted. You can find information there. On the web page, you'll see the recording I did for news updates and hot update. Also, you'll find the 2020 SAC tests and keys. And if you didn't get to see the recordings of the CapCon, both those are there as well. On October 29th, when you get this, you will see this particular recording, and you will see another recording called Bases, which I did because I didn't have enough problems to answer questions on today, so I made another session called Bases. And then on November 4th, there will be a coaches chat for coaches only, where they can chat with me about anything that you might need questions on. So we're going to get started. First off, somebody emailed and asked what happened to last year's regional state test. We were given the option to release the tests or to keep them for future use. I chose to keep them for this year. You will see all of last year's regional and state questions on my tests this year that I write. Of course, you probably won't know which ones were from last year and which ones are this year's, but you will see them all. I felt like I wanted those questions to be seen in a competitive situation. So you will see them as we go along. Okay, moving along. Let's talk about the 2020 SAC number sense test. There's nothing special on there or unusual or much different. I'll call attention to a couple of problems. Number 23, this is an older problem we used to deal with over the time. You may want to take a look at these type problems. They're pretty interesting. Number 42, the length of the median to the hypotenuse, is not new, but I wanted to call your attention to the fact that that problem can be stated 3 different ways, and they have 3 different approaches and 3 different answers. So be sure your students pay attention to what it says. There is a big difference between the length of the median to the hypotenuse, the length of the median to a side of a non-right triangle, and the length of the altitude to the hypotenuse. So be sure you look at that. And also, for those that like to venture into something neat and unusual, number 76 is a rather interesting problem. It can show up earlier in the test, but on this particular test, it's on number 76. Other than that, the SAC test should give you an idea of what this year's tests are going to look like. The SAC math test is only 30 questions because it's just used for the SAC. All math tests are 60 questions. All of them are multiple choice. There are some fill in blanks on the SAC test, but I just do that because I want to have a little fun with fill in the blank. But the regular tests throughout the year are multiple choice. The problems are listed on the SAC math test are in order as to how I write them. And you'll see a little letter in front of the number. For example, A4 means that's an algebra problem. Problem number 4 is algebra. And number M25, that's a miscellaneous problem. And it has numbers. So they'll be listed with those letters to let you know what the areas that I'm writing questions from. However, That will not be that way on a regular test. Students can take A4 there, and they can use their calculator pretty regularly, throw that in there, and it will factor it out for you. And it's a very simple problem. I would recommend that your students learn to factor well, and they can do this problem in probably half the time by knowing how to factor than it takes them to plug it into the calculator. So it's your choice, but I'm truly really trying to get the students to see if they can actually do factoring themselves. M25, we started doing some standard deviation and statistics problems last year, and we're going to do even more this year and go a little deeper into statistics. So I thought I'd mention that as well. Okay, let's move on. When I did my session on October 1st, I asked everyone to look at the SAC math test and number sense test and send me questions that they might have, and I would answer them in this session. Unfortunately, I only received one number sense question, and it wasn't even on the SAC test, but it is a good question. And then I received 8 or 9, maybe 10 math questions. Only one which was on the SAC, the rest of them were older tests. So I'm going to answer those questions the best I can. And then the next session that I'm recording will be on bases, because I think bases is a good thing to look at. So here's the number sense problem that was emailed to me, 21 times 23 over 25. And of course, the answer is 19 over 8/25. The question becomes, where did the 19 and the 8 come from? Well, if you look below there, you can take the 23 and you can subtract the 21 and you'll get 19. And you can take the 25 and you can subtract the 21. And then you can take the 25 and subtract the 23. And if you multiply those, you should get the 8. It's a rather nice little, I want to say, trick. There are no real tricks in math, in number sense. They're all math strategies, but we refer to them as tricks, and that's okay. So that's the way that looks. In general, anytime you have A times B over C, where B is smaller than C, you can use this technique in general terms to solve these kind of problems. So once again, if you take the 19 and you subtract the 17, I'm sorry, if you take the 19, my apologies, let me back up, please. You take the 22 and subtract the 19, the difference between those, and subtract that from 17, you'll get 14. And I think I mistold you about that a while ago. Let me go back here. Yes, if you take the 25 and subtract the 23 and then subtract that from the 21, so this is an incorrect statement here. This should be 25 minus 23 is equal to 2, and then 21 minus 2 is equal to the 19. So this is an incorrect statement here. I'm sorry about that. I just now caught that little issue. So anyways, you have to subtract, take the difference between 23 and 25, and then you subtract that from the numerator, and that's where the 19 comes from. So back over here, 22 take away 19 is 3, and 17 take, oops, sorry about that, and 17 take away 3 will get you to 14. Then we take the difference between the 22 and the 17 and get the 5. And then we take the difference between 22 and 19 and we get to 3. And so you end up with 15 over 22. And that's how that works. So if you get used to doing that and do it correctly, and don't mess up like I did on the first one, the problem goes pretty straightforward. Okay. Moving right along, we're going to do some math problems. That was the only number size problem I got. So we're going to do some math problems. However, you're going to notice on the math problems, I do not list the answer choices because I'm not here to help you find the answer. I'm here to try to give you guidance and hints on how to reach the answer. So I will let you and your students computate and try to figure out what the answer is. This problem was listed like as it is there. It did not have a picture as it appeared, the picture is there. I drew the picture myself to help you see what's going on. So we have a triangle, PQR. It's a very peculiar triangle. Don't laugh, it was meant to be funny. And it exists such that PQ is 4, PR is 6, QR is 9, and there's a point K such that PK bisects the angle QPR, which means it puts angle A and angle A are both the same. Okay. Now, with that in mind, we're going to try to find out what X is. So what we have to do is figure out how we're going to do this. If you take and fold this part of this triangle across this line right here, you will see that you have symmetric triangles. Once they become symmetric, you know the ratio of the sides are equal. With that in mind, you ought to be able to solve this problem relatively fast. Since 4 over 6 is going to be the same as X over 9 minus 6. And you ought to be able to solve that problem relatively simple. All right, let's move on. Here's another problem that was written. It's from TMSCA 6 last year. There was no drawing. I like problems that require the students to do drawings because most of life situations are problems that need to be graphed or written out or drawn or something in order to help them find the actual answer. So I like those type of problems. Now, in this particular case, we have a distance from here to there is 80 kilometers on a bearing of 240 degrees. All bearings start at the north and go clockwise. So if you realize this goes here to here, it goes over 180 degrees, and then it ends up, excuse me a second, it ends up over here. Okay. Now, since this is 180, that must be 60. Okay. Likewise, you have from here to yonder is 60 kilometers, a bearing of 120. So there's 90, and then there's 30 more. Okay. Which gives us 120. So we know this is 30. We know that's 60. You certainly ought to know what that is. And of course, once we know this angle and these dimensions, we ought to be able to solve that using the law of cosines. Okay, all right, moving along. Next one. Now this one actually was a problem that had the drawing given to you. What we're trying to do here is find the length of the rectangle if the rectangle is has a maximum area. Anytime you get to thinking about maximums on problems, you tend to think about calculus, and you tend to think about derivatives and things like that. So keep that in mind when you see that word. A lot of times maximum will refer to some form of derivative. So how do we attack this thing? Let's go over here a second, and let's look at the slope of AB. Slope of AB is 2. Now, where does that come from? Well, you ought to be able to take that and tell me what the slope is pretty quick. Okay? But if you notice that if AB is 2, you'll also know that AE is 2. And if AE is 2, by definition of slope, the slope is the rise over the run, the y over x, you end up with 2 is equal to y over x, which tells us that y is equal to 2x. And that will tell us that that width of that rectangle is right there. Likewise, if you go back here and do the slope of these two, you should find out that the slope of BC is -3, which again tells us that I'm sorry, not that, my apologies, tells us that that is also -3. And once again, since the slope is y over x, you can see that it's going to, that the slope of SC is -3 is going to be y over 10 minus AG. Since this whole thing is 10 and this is AG, we can find out what that is right there. We can find out by taking 10 minus AG. So henceforth, when you crunch that out, you find that the length happens to be that thing, if I didn't make any mistakes. So once you have the width and the length, and then we're going to be dealing with the area, but we're going to be dealing with the maximum area. So I think you can see that you're going to have to develop an area, and then to find the maximum, you're going to have to take the derivative to make all this work. That should get you started on this problem as to where you want to go from here. If you have any other further questions or need more explanation, coaches, please email me. Students, please do not email me. Can't accept students' emails. But coaches, you can always email me about a particular problem, and I'll be sure to give you some more information. Okay, moving on. This one's about merry-go-round, and I'm going to move this thing down a little bit because you can't see it. So move it over here. Maybe you can see it better now. Okay, this is a little bit different from a bearing because it's a north 30 degrees west. Now, I put a red dot there where Mary's camp is, and she's going to travel north 30 degrees west. That means she's going to travel northwest. And so that 30 degrees ends up being right there, based off of that. All right? Northwest, 30 degrees west of north. Okay? And then the other one is 70 degrees east of south. So if you go over here to that one, you're going to go 70 degrees. Now, let me think about this a second. Yeah. No, time out. I have to contemplate this again. It's going to go 7 degrees east of south. Oh, yeah, I'm sorry. Yeah, south to the east. So you're going to take south headed to east. So this whole angle in here is going to be 70 degrees because it went south to east. So with that in mind, and then of course you have your 2 and 2 side, both sides are 2s, which tells you that this triangle is a isosceles triangle. You should know things about isosceles triangles. Base angles are equal. That's these two. They're equal. You ought to be able to figure out this big angle, this angle up here, the small angle, based on what you did with your bearings. And from there, you ought to be able to find out what you're looking for, which is this angle right here, is to get back to camp. So hopefully that will help you get that problem solved. If not, give me a holler. We'll see what we can do. Okay, this is another problem that showed up. And again, I'm a little, my picture gets in the way, I think. Okay, this problem has, we're looking for ordered pairs that satisfy this equation. And I did a little chart for you. First off, if X is at its maximum, Y is 0. And if Y is at its maximum, X is 0. However, we're looking for positive integers. So this one's gone and this one's gone. So that just leaves all those in between there. Now you may be asking yourself, how I did those? Well, this isn't a linear problem. And so Y is going to go up to, up to each time, and X is going to go down 3 each time, as you see, because it's linear. Okay? Now, what you have to understand is that means there are that many. There would be 672 well, there'd be 672 chopped in half solutions because it's skipping by 2. So that's basically how that one of those problems work. Look for the maxims on both sides, and then you can find the things in the middle. Okay, here we go. This is the next one. This one here, the Max Cutter's got a piece of cardboard. He's gonna cut out little squares, as you can see. And you want to know how big a square it's going to cut out. And of course, that would be X squared that they're going to take out of each corner to make this work. But you do realize that if you cut those corners out and you fold this side in, and this side in, and this side in, and this side in, you will create a box. And if you have a box, then you will end up having volume. Once again, there's that maximum thing, which tells us that this problem probably has got something to do with finding derivatives. And since we're working with volumes, we're probably looking for the derivative of a volume. So figure out what the volume is of the box, find the derivative. You should be able to solve for X and find out what X squared is going to be. Okay, next problem. Once again, got a little, there we go. It's getting covered up there. This problem here, again, did not have a drawing. We have a square, and I drew the square for you. Some people are caught up in this thing that all points have to be in some type of logical order. They say it needs to start in the bottom left corner and go to A, B, C, D, and the other one says it should go A, B, C, D counterclockwise. It really doesn't matter as long as you label them. That's what's important. So we have A, B, C, D is our square. We put P in there in such a way that AP is 3.3x, PB is 4.4x, and so on. And we're looking for that angle right there. I hope you realize that these are, since it's a square, this is a right triangle, and that's a right triangle. You certainly ought to be able to use your right triangle formulas to be able to find out what A is. angle A, and what B is. And I think you'll see rather quickly there's a relationship between A, B, and what we're looking for. So that should not be too much of a problem once you see the picture. All right, then we'll go to this one. Once again, there we go. This is a hot air balloon. It's going straight up, and there is a range finder 500 feet from the liftoff point, and the rangefinder is following the balloon. As the balloon goes up, the angle gets bigger. It increases. Now, and it's increasing at a certain rate. Well, these type of problems, when this is happening at a certain rate at a certain time, this involves calculus once again, and involves derivatives. We're going to have to be able to look at the derivative of theta, or x in this case, in respect to time. And then we're going to have to look at the derivative of the height as with respect to time. And since it's a right triangle, you realize that it's going to be involving Pythagorean formula in order to find these derivatives. So, yeah, find your derivative of x with derivative of time, which is 0.1. Get your Pythagorean theorem in there. Find yourself a derivative, and I think this thing should all work out pretty nice. And this is one that very similar to what we did earlier, except in this particular case. Let me see if I can get this thing to move again. Keep getting it blocked out. There we go. This one is very similar to the one we did earlier. You're on a bearing of 200 degrees, which means you're going to go all the way, oh, sorry about that. You're going to go all the way around to here. And then you have a bearing of 100 degrees, which you're going to go to here. And you ought to be able to figure out what this angle is. And then you'll have the two sides and the angle, and you ought to be able to find the question marks. Very similar to the one we did a little bit earlier. So we'll move on. This one is a probability problem. I want you all to know, and of course you probably already know this, probability is one of the most difficult concepts in mathematics. There are very few people that truly understand it well, including myself. I understand it pretty well, but it still confuses me. So probability is not a real easy concept. I don't think we do it justice in the classroom. I think we need to be doing more, but I don't think we do. But it is the way it is. So this particular problem, because it gives you the type of information it does, has to be done through a binomial distribution, because you're going to have to keep in mind that some people are supporting, some people are non-supporting. So you use the binomial distribution formula, which is that thing right there. And you can see I took the values and I plugged it in. The 0.26, of course, is given. And of course, if 0.26 support it, then 0.744 do not support it. And that's where the 0.74 comes from. So it's a probability distribution problem. You might want to look up some of these type of problems that are interesting to see and know when to use this formula and when not to. So it's a relatively nice formula. Okay. So this one here, make sure I move my picture so you can see. There you go. Okay, we have a acute scaling, which I hope your kids can identify why it's acute and why it's scaling. And we have K being put on opposite of the PRQ angle, and so that forms a equilateral triangle. And of course, you should know equilateral triangles. You should know what these angles are in here. Okay? And then if you draw the perpendicular of the equilateral, you ought to know what it does to these two angles. So you ought to know that's 30, and you ought to know that's 30. And what we're going to try to do is find out what this one right here is by doing some mathematics. And I think if you look at that thing, you should be able to figure out how we're going to go about solving that, because you have to understand you do have a right triangle in there when you draw that hypotenuse. So you have an equilateral triangle, you have a scalene triangle, and you have a right triangle, and you have the information. You ought to be able to come up with this answer based off of this picture once it's been drawn. Okay, that just about wraps it up. If you need some more extra help with any of these problems or any other problems, coaches, I suggest you email me. I will respond to you and I will try to give you as many hints as I can without working the problem for you, because I really want the students and the coaches to work the problems. I can work them, so I want you to work at them. But if you need more guidance on any of these problems or any other problems, coaches, email me. I'll see what we can do about taking care of it. Other than that, I wish we were once again seeing each other doing these SACs, but we're not. So it is what it is. Coaches, maybe I'll get to talk to you on November 4th. Be sure you look at the schedule on the UIL webpage in case there's any changes. For now, stay safe. Good luck, work hard, play fair, because now I'm going off on another tangent. Bye.